Hello everyone, welcome to Analyzing the Online Food Dataset Machine Learning Project. So our step 1 is to load and prepare the dataset. First, we'll load the dataset. Let's back to our Jupyter notebook. Let's open this Jupyter notebook. So first, we are importing all necessary libraries like NumPy, Pandas, Scikit-learn, etc. Then our first step is to load the dataset. So we loaded our dataset as df is equal to pd dot read excel because we have excel file given. That's why read excel, and then we give the you can say location of our excel file, and df dot head to print the five you can say top five well you can say rows. Let me run this. Now we have to handle the missing value. Before that, what we will do, we will check if there is any duplicate values. If there is any duplicate value, there will that will deleted. First we check the you can say size of our data set. So we have 388 rows and 8 different columns. We use df to drop duplicates. In place is equal to true. In place is equal to true means by dropping the duplicate value, the same data set will save in the you can say TF. So let me run this. If now we will check the shape of this TF, we will get the 280. It means 388 minus 280, 108 rows was you can say duplicate values. Now we have to handle the missing value. For handling missing value, first we have to check if there is any missing value or not. For that, what we will do, df dot is null to check the if there is any null values. So this will give us in booleans. Let me run this. So here you can see this where it is null, it will give as true, and else it is false. Now if we do dot sum, it will count if the you can send true values. So as there is 000 means there is no null values. Now our next task is to encode categorical variables. Apply one hot encoding to the categorical variables. Now we have to we use pd dot you can say get dummies. First we check the so we have gender, marital status, occupation, and education qualification, and our target you can say target variable, that is feedback with object. So we have to one hot encode these five columns. Here I printed all the unique values in you can say in these columns. Here I wrote the four you can say four column in df dot columns. If the data type of df of column is equal to object, then it will print the column name comma dash comma and df of column dot unique. So it will give me the unique values in the df column. Here you can see we printed all the. Now we have to do one hot encoding. For that, what we can do, we will use pd dot get dummies. We get our we give our data frame where you can say with their respective columns. So they all now will give drop first is equal to true, means dropping the first column because for multicollinearity, and if we give if we run this command, we get the values in true or false. So to convert true or false in you can say integer or 1 or 0, we give dot as type int. Let me run this. So we can do one more thing. We can uh, concatenate this data frame with you can say with age, family size, and pin code columns. Or we can do one more thing. We can give df is equal to pd dot get dummies. Here data will be our df, and columns we classify for one hot encoding. We give true first is equal to true and as type is equal to int. So we get the same data set. Now what we have to do, we have to check for outliers, inspect the numerical categories for outliers and address them as needed. Okay, so for you can say a summary of our data set, what we will do, we will tf dot describe. You can see we get the description. So these all are one hot encoding, so we do not need to focus on these. So we have to focus this on just three columns. It is pin code, so there is no kind of outlier in this. We have main focus on age and family size. So we have three different ways to check the outliers. One is by observing this table, or you can say summary of the data frame. Another is by plotting a box plot. Here, this line is giving me the minimum value, and this line is for maximum. It is our first quartile. It is our second quartile, which is median, and this is our third quartile. And all these dots are our outliers. And one another ways to, I defined a function here for calculating outliers. So here what we are doing, we are giving our column here. First we are calculating q1, that is our quartile 1. Then we are calculating third quartile, and we are then subtracting q3 minus q1 so that we get the interquartile range. uh, then we are calculating lower bound. We know lower bound is equal to q1 minus 1.5 times of interquartile range, and upper bound is equal to q3 plus 1.5 times of interquartile range. And we created an empty list of outliers. Now we for you can say we start a for loop. We are retrieving every value of the array, or you can say our column. So for I in array, if I, you can say our value is less than lower bound or greater than upper bound, then it will append this in outliers. So let me run this. You can see we are giving here df of age, and we retrieve all the outliers. So now we have to handle the outliers. So what we are doing, for all the outliers, if you can say if the value is lower than lower bound, then we are replacing the value with lower bound, and if this value is greater than upper bound, then we are replacing this value with upper bound. So here we created the function for the replace outliers. Here we are giving the array, or you can say a column of our data frame. Then q1 is equal, first quartile will be array dot quartile 0.25, again third quartile, and then we calculated interquartile range. Same lower bound is equal to quartile 1 minus 1.5 times of IQR. Upper bound is equal to q3 plus 1.5 times of IQR. Now here we are creating a new column. So we get new array is equal to array dot apply. We are applying the you can see this function on our given array. So what we are getting, lambda x is equal to lower bound. If so we are replacing x, you can say value with lower bound if the, you can say, x is less than lower bound. Else if the value is you can we are replacing it with upper bound if the x is greater than upper bound, and if it's lie between lower bound and upper bound, then it will give as x. So we return this new array. Now let me run this. So if you run this, we get this new column. Now what we will do, we will replace this you can say this old df of age with our new df of age with applying replace outliers. Let's run this. By the given this function which we defined here, outlier finder, we checked for our family size also. So here we are getting empty value because there is no outlier. So that's why we do not need to handle any outliers in family size column. Before that, uh, so this is not necessary. Now we have to split data into training and testing set. So for that, what we will do, before converting into training and testing set, we will define an independent variable, that is our uh, we defined independent variable and dependent variable, which is our target and features. So our features are x is equal to df dot drop. So from df data frame, we drop feedback positive column, and we give x is equal to 1 because we have to remove the x's, or you can say we have to remove the column. So that's why we give value as 1. So in our target variable, y is equal to tf of feedback positive. Now we have to convert, you can say now we have to split data into training and testing set. So for that, what we will do, we will define x train comma x test comma y test is equal to train test split x comma y, and test size is equal to 0.2. So our 20% of the data will be for testing set, and our 80% data for training data, and random state is equal to 42. We can give any you can say any integer value. We are doing this for you can say reproducibility, so we get the same results, or you can say same split. So as this is a, you can say, a classification project, that's why I am giving is stratify is equal to y. Here stratify means that's it's split the you can say my data in the same ratio as it is given. So if you can see, let me do by 53. So its ratio in, you can say, for positive, it's 4.28 ratio 1. So if we do one thing, oh, I'm sorry, we have to run 25. Then now if we check y train dot value counts, we get our data in the same ratio. Let me do again, open the calculator and give 182 divided by 42. It will be around 4.28. You can say 4.33. So next, what we are doing, we are scaling our data. So scale is equal to we define standard scaler. Then we you can say fit our data on our xtrain data and save it in xtrain scaled, and then we transform our data of our xtest and save it as xtest saved. Now what we have to do, we have to train an evaluate model. So we defined multiple models here. Let me, so we imported logistic regression, linear discriminant analysis, SVR from SVM, k nearest neighbor classifier, decision tree classifier. From ensemble we imported random forest classifier, ADA boost classifier, gradient boosting classifier, bagging classifier, and from naive we imported ghost naive. No. So first we defined logistic is equal to logistic regression, logistic, then our fit our model, logistic dot fit our using our x train scaled comma y train. Then for you can say evaluating the results, what we have done, we calculated, first we calculated y pred, which is equal to logistic dot predict x underscore test underscore scaled, and then we printed the accuracy score by our, so we imported accuracy score, precision score, recall score, F1 score, confusion matrix, and classification report. Later I will explain you about the classification report, but for this time we are just using these parameters. So we trained here, and now we are printing accuracy score, but we are doing accuracy underscore score. We are giving our y true value, which is our which is saved in our y test, and then y pred value, which is saved in y pred. Similarly for all these values. Let me do one more thing. Let me comment this out. Here you can see we get the accuracy score, we get the precision value, we get the recall value, we get the F1 score, and the confusion matrix. So now I will explain you about the classification report. So what classification report gives us is it gives the complete report of our model. So we do not need to, you can say, calculate these values. It's automatically calculate these values. Just we have to give our y true value, which is our y test, and y pred value. Let's run this. Here you can see, so our precision score for 0 category is 0, and for 1 category is 0.8. Here you can see our precision score is 0.80. For recall, for 0 category it is 0, and for 1 it is 1. Here you can see for F1 score, you can say F1 score for 0 category is 0, and for 1 category is 0.89, which is here, and accuracy score is given by here 0.80, and now what I done for, you can say, reproducibility, I defined this, you can say, in a function. So I defined a new function, defined evaluation. So we have to give our model, we have to give y test, and you can say x underscore test underscore scale. So we calculate the y pred using the model.predict x underscore test underscore scale. Then we calculate the accuracy score, precision score, recall score, F1 score, and confusion matrix. So we run this command. So we get the same value as we do it for, you can say, here, because here it is also logistic model, and here also we are giving the logistic model. So what we are doing for each model, we are training our data set, you can say training our model, and we are calculating its score. So if you can see, now I defined LDA is equal to our next, you can say, model, that is linear discriminant analysis, and we fitted our, so LDA is equal to linear discriminant analysis. LDA dot fit our model using X train scaled and Y train. So we give evaluation of LDA, which is our train model, and Y test, and X underscore test underscore scaled. Here you can see we are getting around, you can say, 0.88 of F1 score. Now for SVC we do the same thing. For K nearest neighbor we did the same thing, and for the decision tree, and so on for each model. Here you can see we are getting our accuracy score to maximum accuracy score. So it is our around 0.8, 0.78, 0.80, 0.80, 0.71, 0.76, 73, 75, 73, and 7. So our maximum score is 0.80. So we are getting maximum for we are getting around same result for both these models. So what we can do, we can hypertune these parameters, this model's parameter, and increase its, you can say, accuracy score. So there is a problem in accuracy score in classification problem, because it's do not give us the accurate value, or you can say the true value or the true essence of the model, how our model is performing. Now I will explain why accuracy score is not the true representation of our model. Let me accuracy score for our two models. So our data set is, so we have 10 points in our data set. Assume for 0 category we have just our 2 points, and for categories 1 we have 8 points. In total we have 10 points. We created a simple model which gives for all value, it will just give our you can say results as 1. So it will classify as so classify as this point also as 1, and this whole point as 1. So our accuracy score will be correct points, which is our 8, because it's correctly classified these 8 points, and our total points, so total points are 10. So it's giving me around 0.8 of accuracy score. But this is not by observing this accuracy score, anybody will say yes, this is a good model, or you can say great model, but it is not so, because it is not predicting you can say a 0. It is just giving one value. So that's why we have to balance our data set. So what we have to do, so we have to give 8 and 8, or you can say balance our data set. That's why if we calculate our accuracy score now it will 8 by 16, which is 0.5. So this accuracy score, this accuracy is dropped. That's why for using the accuracy score, our main thing is to balance the data set, or we can use the or we can use other score like precision recall. So what we are doing now, our main aim is to balance our data set. So first we check the y dot value counts. Here you can see our data is not balanced. So what we will do, we have different you can say techniques for balancing our data set. In this problem we are using SMOT analysis. In SMOT analysis, what our model will do, so we are creating you can say similar value, or you can say same type of values. So by increasing our you can say minority class, so we are creating uh, around you can say 227 minus 53 new records by SMOT, or you can say by given data. So what we'll do, x underscore balance comma y underscore balance is equal to small dot fit resample x comma y. And if you can see in this y underscore balance, we get the balance data set here. Again what we will do, we splitted our data, again scaled our data, again for you can say each model we predicted our. So now if you can see in random forest, we are getting around 80% accuracy, or you can say precision of 0.8 and recall of 0.8. So in the confusion matrix also you can see we are classifying the true positive and the true negative. So this model is performing better than you can say our previous model. Uh, you can say this one. So there is more things which we can do to you can say improve this model. So we can hyper tune our models parameter, also we can increase our data set, also feature selection, so that we get the you can say most important features, and we trained using that features. So there is many different tricks, or you can say techniques to improve our data set, or you can say improve our model performance. Thank you.